Welcome. My name is Yu Yin, and today I want to talk about a rather popular topic in generative AI. It is RAG, or Retrieval Augmented Generation. Before we go into RAG, I'd like to touch about some background. What are exactly large language models? So let's dive into it. A large language model, typically today we are talking about GPTs, which stand for Generative Pre-trained Transformers. And what's a transformer? A transformer takes text as input. It can also take images and videos these days, but generally it takes text as input and creates or generates output text. In our outline, let's talk about the thing that started the entire Gen AI revolution, ChatGPT. It really is a chatbot. So let's scroll back. So what is a chatbot? Gen AI chatbot converses with a user, a human user, and it captures this conversation as text and provides it to the large language model to generate a response. So as you continue conversing with, let's say, ChatGPT, it keeps track of the entire conversation. So as your conversation progresses, the input to the large language model also accordingly grows, and it's providing more and more context to the large language model so that it can provide or generate a more appropriate or accurate response to you. So where does RAG come into the picture? RAG comes into the picture because in most automated systems, in most business type queries, we have one question. It's a one-shot input. It's a one-time query. So this is where we can take a one-time input. It takes this one-time input and retrieves a set of relevant documents. Where do these documents come from? They come from your organization itself. We'll talk about it a lot more in later slides, but it's essential to know that it takes the input and it compares it against all your documents in your organization, and it retrieves a set of the most relevant documents and packages it together with your input, and then sends the whole lot to the large language model. So this way it simulates what a chatbot does. Instead of just one input, it takes your input plus a set of relevant documents and asks the large language model to generate output based on that augmented input. That's why it's called Retrieval Augmented Generation. So let's dive into how it actually works. So here's the big picture. Here are the few actors involved, but let's focus on the important stuff. You, the user, and the app you're interacting with. So you typically type in a question in text to the app, and later the app will give you an answer. But here's what goes on behind the scenes. The first thing the application does is it converts your input, your single input, the ones you typed in, into an embedding. An embedding is nothing more than a mathematical vector. It's an arrow pointing in n-dimensional space. It asks a vector generator to do this, and there are many libraries that can do this, but one library I'm familiar with is the Llama Index library. So the Llama Index library would be able to get you an embedding for your input. So it returns an embedding. With this embedding, your application will call a vector database, and you'll ask the vector database to do vector algebra. With this vector I'm giving you, please find me, let's say, 3 documents that most closely match this vector. So vector dot products, and that standard vector high school vector algebra. And it comes back with, well, the 3 most closely matching documents. Here are the documents. Now you have these 3 documents and the original input, and you send it over all the way from application to the large language model. And with this large language model, it returns the response to your app, which then forwards it to the user. So for those of you listening closely, you find that this stage over here is an issue. How are we going to get the three most relevant documents? This is where a vector store comes in. So how does the vector store get its powers? Well, every organization has a store or registry or repository for its documents. I can write a software robot, I'll call this software robot a scanner, and the robot's role in life is when it wakes up, it looks for the document repository. And when it finds the document repository, and if it's the first time it's seeing the document repository, it will ask for all the documents and will ask a vector database to index these documents, right? And store it as vector embeddings in the vector database. And then subsequently, as documents are added over time, as documents are updated and documents are changed, this same scanner will look for changes in the document repository and update the vector database. Now focus on this path in red, where API is asking for retrieval end documents, right? This on conversation or request reply over here actually reflects this conversation. So there we have it. Retrieval Augmented Generation. Thank you for listening.